For Associate Professor Wai Hong Tom, the quest to better understand malaria started with trying to answer a question.
How one of the really most widespread malaria parasites actually get into your human blood. In particular, they get into really young red blood cells.
Oh, okay.
Yeah.
It took an international team of scientists, including the Melbourne researcher, and a unique approach to finding the answer that no one had discovered before. They focused on a parasite carried by mosquitoes and the process it uses to infect humans.
It is actually a very specific interaction between a human protein and a parasite protein, and we call those lock and key interactions. And so if you can actually stop the key from entering the lock, you can actually stop the parasite from getting into the blood.
Scientists say malaria has existed for centuries and used that time to adapt and become highly resistant.
The malaria parasite is very smart. It's able to change its spots, like a tiger changing its spots. It can essentially change the way it looks, and so it becomes invisible to the humans that it infects and continue to cause disease and be passed on to the next human via a mosquito.
Researchers say they've made great progress in combating malaria, reducing the number of deaths in the last decade by roughly 50%. But it still manages to affect about 200 million people around the globe and kills nearly 500,000 each year. And according to the Centers for Disease Control and Prevention, it remains the leading cause of death and disease in many developing countries.
Yeah, so it's quite a lovely result.
Wai Hong Tom says the information that she and other researchers have uncovered could lead to a highly effective vaccine because they've figured out a way to use antibodies to block the parasite from getting into red blood cells. And scientists believe that process could one day help stop infections from other deadly diseases.
Through vaccination, actually elicit human antibodies that can then actually block this parasite from recognizing the protein and essentially stop entry into these young red cells.
Tom and other researchers plan to use antibodies on the same parasite found in different parts of the world to test just how effective their discovery really is. Greg Navarro, CGTN, Melbourne.